Exponents. Today we're going to be talking about exponents. Sometimes in math you may see a problem and you will see a whole number written large like normal here, but you will see a little teeny number up here. This little teeny number is called an exponent. Exponents are used to show repetition of multiplication. Example: 10 squared, we say that number 2, we say squared means, or 10 to the second I should say, equals 10 times 10. And if you see, there's 1, 2 tens. And that's what this 2 means, that there's 2 tens. 2 of these, or 2, this times this times this. 10 times 10. But there are 2 tens being multiplied. So then what happens if you have 10 to the fourth power, or 10 with the 4 up there? And that means, very simply, there's 10, 2 tens, 3 tens, and 4 tens. 1, 2, 3, 4, and that equals this. All times each other. Now, what is that going to do? What kind of number would that make? Let's go back. Okay, well, let's see what that will make. Go over here and let's look at our 10 to the 2, or 10 times 10. And we get 10 times 10 equals 100. Of course, you could, use your strategies. Here's another strategy you can use. You could do the dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then you can make 10 rows of that. Let's see if we can fit that on there. We might be able to. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 4, 2, 3, 4, 5, 6, 7, 8, 9, 10. 5, 2, 3, 4, 5, 6, 7, 8, 9, 10. 6, 2, 3, 4, 5, 6, 7, 8, 9, 10. 7, 1, 2, 3, 4, 5, 6, 7, 2, 3, 4, 5, 6, 7, 8, 9, 10. 8, 2, 3, 4, 5, 6, 7, 8, 9, 10. 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the last one, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we could count them all up. We can count by tens. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So we know that it gives us 100. So we have the 100. But if you look at that, you'll see that you started with 10, and you did that 2. You moved it over, the decimal over one space, and added a 0. Now, let's see if that would work out and fit with the 4 also. We start out with the 10, and then we go over 10 times 10 becomes 100. times 10 becomes 1,000 times 10 becomes 10,000. So look at the zeros. 1, 2, 3, 4. 4 zeros. And the 4. Let's look here at this one. 1, 2 zeros and then 2. Look at that. But that will only work with the tens. For example, let's look at the 3's right here. 3 to the third means repetition of multiplication. 3 times 3 times 3. 1, 2, 3 to match this 3 and all multiplied. 3 times 3 we know is 9. 9 times the, oops. Let's mark those off so that I don't accidentally do them twice. 3 times 3 is 9. It leaves me with times 3 left. 9 times 3 equals 27. See how that doesn't, you can't always do the moving the decimals over, but you can with tens, hundreds, thousands, with those zeros. Okay. And that is what exponents are and what they mean and how to multiply them out. When we talk about exponents, and we usually use tens at the beginning, we inevitably get it back into the discussion of multiplying by tens or numbers with 1 and 0 and dividing by tens or numbers with 1 or 0. And they kind of go hand in hand, so it's a good time to review this. When we're multiplying something, for example, 10 times 10, which we've already memorized because of our times table, we know is 100. Look at that. We start out with 10, which had how many zeros? 1. And we ended up with 100, which had how many zeros? So we have 1 0 that we started with, and we essentially added 1 0 to it. That decimal point went from here to here. So when we multiply, we're moving those decimals to the right. But when we divide, for example, we get 30, which is essentially, we started off with 300, but we ended up with 30. We moved that decimal in this direction towards the left, and we ended up essentially taking away a 0. So when we multiply by tens, we end up adding zeros and moving the decimal point over to the right. When we divide, we end up taking away zeros, and we end up moving that decimal over to the left. And that is my ancient Chinese secret of multiplying and dividing by tens or hundreds. The same thing does work for hundreds. For those of you who don't know, let's see. 10. Oh, let's not do it that way. Hold on. Good. So let's look and see what happened there. We had 300 times 10 to see if we're checking to see if this rule right here makes any sense. Okay, we have 300, which has how many? 1, 2 zeros. We multiply by 10. That first row, 0 times 0 is 0, 0 times 0 is 0, 0 times 3 is 0. We go to the next line, we have to add that other 0, 0. 1 times 0 is another 0, 1 times 0 again is another 0, and 1 times 3 is 3, and we end up with 3,000. How many zeros does 3,000 have? 1, 2, 3. We start with 300, it had 1, 2. Did we add a 0 here? 1, 2, 3? Yes, we did. We added a 0. So that proves it does work. Now, we're looking at the 310, the 300 divided by 10, as shown here, 300 divided by 10, first thing we do, we look at the 10, does it go into 3? No, because it's too big. 10, does it go into 30? Yes, it does. How many times 10? 10 times what is going to give us 30? So we're looking for a number. 10 times 10. 10 times 1 is 10. 10 times 2 is 20. 10 times 3 is 30. So I'm going to look here. Put my 3 over here. Why am I not putting it here? Because remember, 10 was too big to go into 3, so we had our space mark. And I could even put a place marker there. I can put a place marker just to keep our spot there. So 10 times 3 equals 30. Let's continue our division. And 10 times 3 gives us 30 exactly. Okay, so we subtract, we get 0 and 0. 10 won't go into 0, so we have to bring down the other 0. 10 will not go into that either, so it's going to automatically be 0. So again, for division, it also works. We started with 300, we divided by 10, and we ended up with what? 30, which meant there was only 1 0 now, but there was 2, so we did, in fact, take away one of those zeros when we divided. And that, my friends, is the ancient Chinese secret of multiplying and dividing by tens.